Hello everyone, I'm Yan Yuna. I'm very happy to do this presentation and share with you about SuperMap AI GIS technology. As we all know, AI is widely used in our life and work. For example, driverless cars, face recognition, and smart assistant on mobile phones. If you have an Apple phone, I believe the most common sentence you see must be "Hi Siri." Let's take a look at the history of the development of AI. As with all technological developments, AI research has experienced troughs and booms. People's enthusiasm for AI is up, down, and the rise of deep learning has driven the climax of artificial intelligence development today. As can be seen from this PowerPoint, AI includes a lot of content, such as natural language processing, computer vision, speech recognition, and so on. Machine learning is the technical core of AI at this stage and contains many algorithms such as EBK, RF, and SVM, and so on. And deep learning is a subset of machine learning and contains multiple neural network algorithms such as CNN or RNN. Its appearance makes people more confident about the bright future of AI. So, what kinds of spark can be generated by the meeting of AI and GIS? It's AI GIS. But what's it? It's one of the technical systems of BitCC, and the BitCC is a summary of SuperMap technology through continuous technical iteration. And the AI GIS provides three major functions: GeoAI, AI for GIS, GIS for AI. Firstly, let's take a look at GeoAI. GeoAI is based on statistic algorithms, machine learning algorithms, and deep learning algorithms. It solves problems in the geospatial domain and performs geospatial data processing, analysis, mining, and comprehensive model. It contains two algorithms, geospatial machine learning and geospatial deep learning. For geospatial machine learning algorithms, SuperMap provides some operators as follows, including three types: clustering, classification, and regression. Now, let's take forest-based regression analysis as an example. The typical application of the regression model is to model and predict housing prices in different regions. Here, we use some housing transaction data for modeling, including transportation, education, and medical infrastructure. In the modeling process, regression modeling is carried out with the distance to the infrastructure and the number of infrastructure within a certain distance as explanatory variables based on the model. Other real estate prices can be predicted. This is an estimate of housing prices in Beijing. You can see from this picture, the housing prices in city center are relatively expensive, but the suburbs are cheaper. And our common sense also verifies the conclusion from the site. Next, let's take a look at geospatial deep learning. Before that, we need to clarify the difference between the geospatial machine learning and the geospatial deep learning. The application of both algorithms includes four processors: inputs, feature extraction classification output. However, geospatial deep learning can automatically extract the features, while geospatial machine learning can't, and requires human assistance. So, the geospatial deep learning is more intelligent and convenient. For geospatial deep learning algorithms, SuperMap provides some operators as follows. It includes object detection, binary classification, scene classification, and land use classification. Because these operators are more practical and used in many related projects, we will introduce them in detail. About object detection, we have supported a lot of objects. As long as you have enough training data, we will try to identify anything, such as plane, pool, and tennis court, and the accuracy is affected by image accuracy and simple conditions. And greenhouse. The picture shows the detection results of the greenhouse in a certain area. The yellow frame is the detected greenhouse, which can locate the distribution, location, and the quantity of the greenhouse, and provide basic data support for the greenhouse management. In the refined management of agriculture by identifying and counting the number of greenhouses, we can understand the agricultural development status and the land use distribution in the region. And this is the detection results of the sheep. And this is the car. In the scene where object detection, the number of cars can be identified and counted at the same time to estimate the traffic flow and operation of the parking lot. At the same time, SuperMap also supports object detection and statistical analysis of economic traits to improve the level of agricultural refinement. About binary classification. Binary classification can be used in image to distinguish buildings or not buildings. SuperMap uses the geospatial deep learning algorithm to classify a certain type of feature in the reconnaissance image and determine whether the image pixel is building and generate binary result data with values 0 and 1. The 1 is building and the 0 is not building. We set the zero value areas to transparent color, which looks clear and has a better effect. In addition, the extract results can also be automatically vectorized so as to obtain information such as the location and the vector boundary of each building. Based on this function, we participate in the competition called the Open City AI Challenge, building segmentation for improving resilience to disasters, organized by GDRRF, One Foundation. Using binary classification to identify the buildings from Drew areas image in various cities in Africa. The effect is not bad. This result helps us to understand the specific location of buildings and the patient risk of disaster damage and help cities manage disaster risk. At the same time, using the binary classification, route extraction can also be carried out. It saves a lot of time for data collectors. About land use classification, this is a typical application. Divide land use classification into water, construction land, and farmland. It can often be used for a variety of applications related to land cover information, such as deforestation and urbanization in monitoring areas, urban planning, and road monitoring. For those GeoAI, SuperMap provides two ways to use. One is tools, and the other is methods. With these ready-to-use tools, users only need to enter their own geospatial data and perform calculations to obtain results. Method refers to provide full process GeoAI capabilities, including prepared data, model building, and the model application. The method is targeted, and the results of model application are more accurate. But users need to spend a lot of time to prepare training data and train the model. And this is desktop product of SuperMap. When ready to use tools, the product provides the function to use directly, such as object detection, binary classification, multiple classification, and scene classification. And this is server products, another ready-to-use tools, machine learning service. The product provides the function to use directly, such as binary classification, land classification, object detection, and so on. Similarly, desktop products provide method support, including prepared data, model training, and model application, such as object detection, and it's suited for short-term work. Similarly, server product supports the same function, named Data Science Service. In addition to the Python library of SuperMap, the Data Science Service has built-in third-party libraries to provide a more comprehensive and powerful data science capability. The entire data analysis and the calculation process is displayed through the notebook editor, and it's suitable for long-term work. The demo is the process of land use classification using SuperMap Data Science Service, including simple generation, model training, model application. The final result can be quickly displayed in the edit. And the second part, AI for GIS. Using AI technology to improve the intelligence level of GIS software, including 4 functions: AI attribution collection, AI survey and mapping, AI cartography, and AI interaction. About AI attribute calculation, in our smart city management, we found some illegal cases or some problems that we need to record. For example, there is an illegal parking. Once we take a scan of it by phone, we can recognize that it's a black car with a blue license plate. We don't need to fill in manually. This information will be automatically identified and filled into the system. Using AI attribute collection, we can get the type, color, location, time, picture, and license plate number, license plate color of the car, and many more other informations. AI survey and mapping. Previously, indoor data collection was very expensive, but now, to obtain available indoor maps, only rely on a mobile phone and an app. This is exciting for regions lacking geospatial data. And the app called SuperMap iTablet. In addition to provide AI survey and mapping function, it also provides data processing, map view, 3D sense view function. And everyone can download from the SuperMap's website or App Store. Pick up your phone, search for it in the App Store. You can download and use it. It is currently free, and if you try it, you will like it, I think. If you are a GISer, do you feel manual mapping is too annoying? AI cartography can using AI algorithms to learn the input picture style and transfer the picture style to the target map, which can improve the efficiency and the effect of GIS mapping. We selected 4 pictures about the spring, summer, autumn, and winter and applied their color scheme to the map to quickly complete the mapping. Of course, you can also choose a professional map as a reference. The maps made in this way are more standard. At the same time, SuperMap also provides AI interaction capabilities. We can use gestures or limb to control the map. This demo shows the use of gesture to move, zoom in and out of the map. As we can see, the map is 2D map. And this is a 3D map. We can also use gestures to control the map, all the scenes. We can move it and we can zoom in and out. And we can rotation. Similarly, we can also use our limbs to control the map. But moving, zooming and out, rotation, and control the layers. The third part, GIS for AI. GIS can give AI more ability of geospatial visualization and geospatial analysis, and further process and analyze AI analysis results in GIS software. In the traffic simulation monitoring and control system, AI is used for object detection to identify people, cars, motorcycles, trucks in the camera video, and GIS has shown the results via heat map. All information is displayed in the dashboard, allowing people to understand the traffic situation in real time. In the real-time AI video recognition platform, during geographic fences, the yellow color areas this to represent bus lanes, monitor illegal vehicles when it occupies bus lane. When the car enters the geo fence, it means that the bus lane is illegally occupied. In this way, violation monitoring based on geo fence is realized. Last but not least, we have a summary. This is AI GIS Technology System of SuperMap. It includes data, library, framework, and function. Data library framework belong to basic support and introduces less due to the time. And the core function, which spent a lot of time introducing, Geo AI, AI for GIS, GIS for AI. And we know that Geo AI contains two algorithms, Geospatial machine learning algorithms and Geospatial deep learning algorithms. At the same time, SuperMap provides flow tools to implement these algorithms. And this is Geo AI. AI for GIS contains four functions: AI attribute collection, AI survey and mapping, AI cartography, and AI interaction. And this is AI for GIS. And GIS for AI. It contains two functions: spatial visualization and spatial analysis. And this is GIS for AI. So, how can these functions be implemented? Yes, relying on SuperMap products, including component products, server products, and various end products, such as PC product, web product, and mobile product. We can choose according to our own needs. For example, if you want to use GeoAI function, you can choose SuperMap iObjects, SuperMap iServer, SuperMap iDesktop X, or SuperMap iClient. And if you want to use AI for GIS or GIS for AI, you can choose SuperMap iMobile or SuperMap iTablet or SuperMap iDesktop X. Okay, that's all. Thanks for your patience.